Alright guys, today we are going to have a shorter lesson on how to use the Pythagorean Theorem, what we learned yesterday, but how do we apply that to word problems? So I left you a note that I actually want you to write down in your notebooks, so please do so. I want you to write down the note that when you have word problems, you want to set up the problem by drawing a picture first. That's the big point. Maybe underline it even. Draw a picture. Once you draw the picture, then it's way easier then to use the Pythagorean theorem, which is a squared plus b squared equals c squared, to solve the problem. So I'm going to say it one more time. Draw the picture first. Now, sometimes on word problems, they give you the picture, which is awful nice. Sometimes you have to do it yourself. So let's take a look at an example of what I mean. This word problem, it isn't really a story problem, but it is a word problem. It says, what is the length of the hypotenuse of a triangle that has the coordinates -4, 0, -4, 5, and 0, 5. Now again, like I said, you just need to draw a picture first. So let's just take a look. I have -4, 0. So that's left 4, 1, 2, 3, 4, and up 0, which means I don't go up anything at all. So -4, 0 is right there. I also have -4, 5. So that's left 4 again, 1, 2, 3, 4. But up 5. 1, 2, 3, 4. That's right here. I ran out of room a little bit, but I think you get my point. And the other point is at 0, 5. So start at 0. Don't go left or right because of the 0, but I do go up 5. 1, 2, 3, 4, 5. Now these 3 points make a triangle, so I'm going to draw a triangle. Okay. Now the next thing I want to do is find where is my right angle. Which one makes a 90-degree right angle, kind of looks like an L. Well, this looks pretty short. I don't think that makes the right angle. I don't think this one makes the right angle. And this one's pretty obvious. This is your right angle right here. Okay? So we have a leg on this side, a leg on this side, and a slanted line, which is your hypotenuse. Now, I got to figure out at least 2 of these sides to figure out the third. When things are straight up and down or straight left and right, I can just count the squares. I can go 1, 2, 3, 4, 5. So this is a distance of 5 because it has 5 squares. You can do the same thing if it's straight left and right. So I'm going to go 1, 2, 3, 4. So I'm going to write that inside because of the text up above. So this side is 5, this side is 4. When it is a slanted diagonal line, I cannot just count squares. There's no way to do that, and you will always have to use the Pythagorean theorem to do that. So I'm just going to call that x for right now. So again, using the Pythagorean theorem, I'm going to go a squared plus b squared equals c squared. And I'm going to put the 5 and the 4. These are my 2 legs because they both touch the right angle. And the nice thing about these kind of problems is these will always be legs, so you'll know that. So I'm going to go 5 squared plus 4 squared equals c squared. Well, let's see. 5 squared is 25. 5 times 5. 4 squared is 16. And c squared, well, I'll just put it in the x squared. Okay, I can combine these terms because they're on the same side. So 25 and 16 is 41 equals x squared. And what's my last step always? My last step is to always take the square root. So I'm left with x equals, and the square root of 41. Okay, the square root of 41 is 6.40. And if it doesn't say so, I want you to start rounding to 2 decimal spots. If it doesn't tell you something different, always round to 2 decimal spots. Okay? So that's how you're going to do a problem if it gives you 3 points and you have to draw the legs and come up with the hypotenuse. So let's see how we do on an actual story problem. So in this story problem, we have a traffic helicopter, and it flies 10 miles due north and then 24 miles due east. Then the traffic helicopter flies in a straight line back to its starting point. What was the distance of the helicopter's last leg back to its starting point? Okay, so again, my one tip for today, draw a picture. So I've got a helicopter. I don't know if I can draw a helicopter very well. See, they have little legs on them, and a tail with propellers on them, and a little propeller up top. All right, so there's my helicopter. Beautiful. First thing it says is that my helicopter flies 10 miles north. So north is usually indicated by up, so I'm going to go up 10 miles. And then flies 24 miles due east. Now, if you don't know what east is to the right, west would be to the left. So it's going to go 24 miles east. I'm going to make that a little longer, twice as long as 10. So that's 24 miles east. And then it's going to fly straight back. Helicopters are nice because they don't have to stay on road, so it flies straight back home. That was pretty much straight. And it says, what was the distance of the helicopter's last leg back to its starting point? It wants to know what is that distance that we just drew right there, and that is x. Well, if you notice, what kind of picture did we draw? It's a right triangle. And what can we use with right triangles? Well, we can use a squared plus b squared equals c squared. Let's see where I'm going to put things in. The 10 is touching the right angle, so that's a leg. The 24 is touching a right angle, so that's another leg. And I don't know what x is. X squared is my hypotenuse because it's not touching that. Okay, 10 squared is 100. 24 squared, if I remember right, is 576. Let me see. It is 576. That still equals x squared. Okay, let's add those together. Well, 100 plus 576 is 676. And what's my last step always? Well, I always square root both sides. And I find out that x equals, I believe that's 26. Let me see if that's right. Sure enough, that is 26. The square root of 676 is 26. So what was the distance of the helicopter's last leg back to its starting point? 26 miles. Now you have to be careful with story problems, as sometimes, even though you find that third side, it asks you different questions. One question it might ask you is, what was the total distance around, or how far did it fly in total? Well, then you would have to go 10 plus 24 plus 26. Another question it might ask, which I've seen a lot, is it'll ask how much shorter was the straight trip home than the first two legs. So you would have to kind of compare the 34 between these two legs to the 26 and find out the shortcut was 8 miles. I'm just giving you some problems that they might ask you, so make sure you pay attention to the question it asks. Like I said, in this case it asks, what was the distance of the last leg? So you could just stop with 26 miles. Now I'm going to give you a little hint. If you're watching this video before Wednesday's activity, both of these story problems are exactly ones that are on the activity for Wednesday. So if you copy those notes down, you'll be ahead of the game. All right, guys, I kept it to 8 minutes. I was trying to get for 5, but didn't make it. So watch the videos, answer the questions, and be ready for class tomorrow. Have a good day.